Some 5,000 light years from Earth, there is a bizarre and mysterious nebula that cloaks an average temperature of just 1 Kelvin, otherwise minus 272.15 degrees Celsius, making it the coldest natural object in the known universe. For decades, scientists have struggled to explain how this otherwise unremarkable cloud of gas maintains temperatures colder than any empty space itself. But now they finally have an answer. Another star took a depth plunge into this dying star's heart. Today we will discuss with you on the topic what's the most coldest thing in the universe and why. Welcome back. This is In Nature's Life. The Boomerang Nebula is thought to be a protoplanetary nebula, which is a transitional phase in a dying star's life that sits between the bulging red giant stage and the finer planetary nebula, a glowing shell of ionized gas ejected from the collapsing red giant. Researchers think that the Boomerang Nebula is so cold because a smaller companion star threw itself into the heart of a larger red giant, causing most of the red giant's matter to be ejected as an ultra-cold outflow of gas and dust. The only way to eject so much mass and at such extreme speeds is from the gravitational energy of two interacting stars, which would explain the puzzling properties of the ultra-cold outflow. This outflow is expanding 10 times faster than it would in a single star, traveling more than 150 kilometers per second, and plunging the protoplanetary nebula into temperatures of just 1 degree Kelvin. To put that into perspective, 0 degrees Kelvin is now known as absolute zero, a potentially impossible point at which all thermodynamic motion stops. It's also colder than the cosmic microwave background, the afterglow of the Big Bang, and the natural background temperatures of empty space, which has an average temperature of 2.725 Kelvin, otherwise minus 270.5 degrees Celsius. Our own sun is predicted to follow this process in the next few billion years. As it runs out of hydrogen fuel, it will swell up into a red giant, endure the intermediary protoplanetary phase for no more than 10,000 years, and then start to shed the outer layers that will form a planetary nebula. The newly exposed core of our sun will continue to cool and shrink and become a white dwarf, a stable star with no nuclear fuel. After billions of years, the white dwarf will lose all of its remaining heat and become a cold black dead star. Scientists now found out that the protoplanetary nebula is now starting to warm, and they think we could find other objects just like it elsewhere in the universe.